Hi everyone, in this video we'll be looking at how we can use gradient descent to come up with the value of w and b, which we will be using in our segment function. So from our previous videos we know the gradient descent is basically coming up with the derivative of our cost function in respective to whatever parameter we are looking to find the gradient descent for. So if you look over here, if we're finding the gradient descent for w, our equation is going to be looking at something like this. So we subtract the actual value from the predicted value and then multiply with the column value of the x input. When it comes to finding the gradient descent of b, we just basically subtract the actual value from the predicted value. And what we do is that we repeat it for all the number of data sets we have got, starting from 1 to the very end point. If you see the equation itself, this equation over here is still the same like our linear regression, but the only difference over here is that the cost function itself is different, and the concepts which are gonna be exactly the same like our linear regression is that we can still monitor the gradient descent, which is the full reason which we're doing it. We can monitor the gradient descent like the way we have been doing in a linear regression model. So we subtract the value of the gradient multiplied by the learning rate till the very point where we reach the minimum cost value, and we can still do the vectorized implementation. So if you look over here, w has got a arrow on its head. That just means that we will be having multiple values of w. So the equation itself can have a lot of parameters, right? It can be x, x1, x2. So the w itself, the vectorized form will be storing all the values of w in the form of vector, and then we will still be doing feature scaling in order to adjust the values in the axis depending upon the need of our gradient descent. This coding exercise is gonna give you a full idea about how the gradient descent work in logistic regression. So what we are doing initially is that we are declaring all the x input in the form of vector, and then we have also got the y label. We have also declared that in the form of vectors as well. So if you look over here, we have got two parameters. One is you can say that one is x1 and the other one is x2, and then you have got the y label corresponding to it. So the first one has got 0 and the second one is 0, and it goes on. So if you look over here, the very thing which we're doing next is computing the gradient logistic. So it's basically returning, so you can see this is returning the dj underscore db and dj underscore dw. This is the gradient descent of b and the gradient descent of dw. So this function will be returning the equation itself, and then we're retaining both of them. And if you see over here, and when we run it, we come up with the value of gradient descent, the rate from here of rate of b and the rate of w. So we're getting the gradients from here. Then afterwards we're actually gonna run the gradient descent. So if you see, what we are doing over here is that we are actually giving the number of iterations as parameter to the gradient descent, and we are declaring the iteration as 10,000 over here. And initially the w value itself is gonna be 0, and the b value is also gonna be 0 as well, and the learning rate is gonna be not that big enough. It's gonna be 0.1, so it's moderate. And so what we are doing over here is that we are subtracting the initial value of the gradient and subtracting it to the very point until we reach the minimum value of cost. So if you see over here, we are not showing out all the outputs, otherwise it's just gonna make the system slower. We're only gonna show the tens and 2000s and the 3000s. We're dividing it up by 10 and showing only a particular ones. So if you see over here, the cost value itself is actually dropping down, and we will be doing it till we have reached the point where we have got 10,000 iteration. So here we can see that we have come up with the w value and b. So for x1 our w is gonna be 5.28. for x2 we're gonna have the w value of 5.08, and if you see over here, we have got a b value of minus 14.22. So we are running the gradient descent over and over again until the cost function has reached its minimum. So that's actually our graph over here. So I will be showing you one other example. So if you see over here, this is for one other data sets. Over here you have got only one x input, and then you have got the y label corresponding to it. So if you look at the cost function in corresponding to b and w, you can see that whenever the cost function itself is minimum, just look at the sigma function itself, see how accurate it actually matches with our model. And the z, I mean the whatever the value we have got for the w and for the b, this itself is the boundary in this case. I hope this all makes sense to you. Just don't hesitate to leave down any questions in the comment section. I'll be more than happy to answer to them. And don't forget to follow me for more machine learning contents. Thank you.